plain.
Well, you could, but that's kind of hard to do. Then you can take some of your saliva, something that sneeze those things. Why don't we try to grow some? The way we're going to grow them is to grow them in petri dishes. Petri dishes have a little layer of a jelly-like material called agar, and this particular agar has nutrients in it. So the bacteria or the microbes, whatever we find, can grow there. You could spit on it. You could sneeze on it. You could take one of these little swabs that are wrapped up in those little containers, which are sterile, and touch it to something, like maybe your hand. Okay? And then you could rub it on the half of the petri dish that you're going to use. Your partner is going to use the other half with a different swab. Does that make sense? The last group didn't seem to understand that.
I seem to understand. They're all boys.
There were a lot of them, weren't there? It's nice to have a girl group and one guy. Yeah. Okay. So once you have sampled, you want to rub that gently on your petri dish, on your half. Now you could not just rub it on there in sort of a random way. You could actually write your initials on it, or draw a little tree, or a heart, or whatever you like to draw. And then the bacteria will grow up in that pattern. Now, we could leave these with Miss Boudreau and have you look at them. But the danger in that is that we don't know what's going to grow up. It might be good bacteria. It might be harmful ones. And while a harmful one might be something that we picked up off my hand, and when we put it on the petri dish, instead of just one bacterium here, I might have billions of them on the petri dish in a couple of days. So we don't want these to be around you for fear they might be dangerous. So instead, how do you suppose we're going to let you see these? Well, no, because, we could, but the problem with that is that we'd have to bring them back and let you look at the microscope.
Take pictures.
Take pictures. So we'll indeed take pictures and send them to you in about a week. And because you have written down the number 43 in the right line, 43, and told us what it is that you were looking at, what it is you said. So was it indeed my hand, or was it the water tank over here, or was it the light switch, or was it the pull on the zipper on your jacket? Whatever it was, write it down.
It's so cool. Do they eat us? Do they eat our dead stuff? Yeah, some people. They don't eat us, right?
Have you ever tried to find
That's
Yes, I have.
So then you put bacteria. Tom,
Well, I had mentioned earlier, it's just a piece of metal. It's not a magnet, but it does conduct electricity. But it's just like a microscope slide. And this is like a sticky dot of carbon, and it's sticky on both sides. So it goes on top of here, and then whatever we want to look at then gets dropped on top of there, so it sticks. And then we coat it with metal and view it.
Hey Jeff, what's the carbon for?
That's the
what we do is cleaning it out. I wish I was going to the next class. Yeah, get the mix right. Like things like makes them so much better. Don't touch it. Oh yeah, you know honeycombs? That'd be like their heads like Caroline.
Right, so a bee and a bug, their eye is not quite like ours. There's something called take all that information and make sense of it.
Kind of usually
K just stands for thousand. So you have to write that out. And then hit save, and you're saving there. Now we have a permanent copy of that. We could look further, but I think we should switch with someone else.
a little bit further on the sides there. On the sides.
See how far we
They get better another volunteer come up.
Okay,
Oh, Tom, that's
wait. Do you want to go higher?
Yeah, let's go
Let's go in on a pair.
Good idea. So what we do is, first of all, she's going to
He has to run the soul. Hit forehead, so you increase your magnification. So when you custom plus buttons.
How many times that? How many times was it? 6,000.
Where did this
How do you guys do that?
Take that top box.
Oh, I did the inside face.
I kind of show the
That goes in here.
Wait. There's 77.
This is on N and 10. This is one hair on the
No, it's one hair on an antenna of a bee.
That's right. Magnified how many times?
1,000, 10,000.
So you pay the limits of resolution on this one. It's the highest like ever.
Microscope, so probably about the smallest one that you can find.
How big is considered a big electron?
Actually, Karen and I have stepped into the biggest scanning electron microscope there
Is
is.
it bigger than the school?
It's not bigger than the school, no, but it was big enough to
Goes
put-
into like the back of a trailer truck.
Yeah, yeah, it's huge, and we were standing in it and had our pictures taken.
What did they do with that magic microscope?
They're looking at bigger things, and they may be able to keep some things alive. They may
Another question?
How heavy is that?
It weighs about, I think it's around 200 to 250 pounds. So it's made to be portable so two people can move it. And it's on these rollers, so the whole cart pulls up to the car and it slides into the back and folds up. So we can take it places and set it up on site. Question?
So how what's the view on that?
Alright, so this one, as we'll see, will go up to about 10,000 tons. So does anybody remember how much magnification you can get with a light microscope? 400, sometimes 1,000. But it's going into the chamber, and I'm going to go ahead and I'm going to start the vacuum here. So because you don't want any air or moisture to interfere with that beam of electrons, it's got to be a good vacuum.
This is the vacuum, external vacuum you're hearing right here, and it's kind of sucking the air and moisture out of this, where we had the chamber open, like sucking air and moisture back out.
That also means that we can't put like a wet sample in there, because what would happen if I put something with water in it in there? Right? And what would that do? Say something was wet. It would, it would evaporate. It would
And it
basically
would also
spoil.
burn though, I really wouldn't want it.
Yeah. So you're lowering the pressure to keep the temperature constant, and the water will evaporate. And if the water is inside like a bug, well, it's just going to pop in there and make a big mess. So yeah, so everything has to be pretty well dry.
The stuff that Jeff put in here, what did you put in there for that?
Put in like a strawberry, eggshell, and
Okay, but this is what that stuff looked like, and it was put on a carbon dot, and it was sprayed with a layer of gold over it, so that the electron beam can actually reflect off of that and provide an image. There's so little gold over here.
yeah, you have to be sputter coating a lot to actually get enough gold right there. to make it. Even the target that we use to create the gold for the film is probably only a few $100. Right. So what's happening is you can hear the sound changing. This is being pumped out of there, and then what will happen is there's another pump inside of here that will start to spin, and that will get all the air out of there. So that's just going to take like a minute or two. And then we'll have a look. So The scanning electron microscope, you can get magnification starting at about 10,000, which is what this is, all the way up to maybe 200,000.